So these are the steps for solving a linear inequality in one variable, and there's more to these steps than we have done so far on this solving. So if you take a look at this, notice it first says clear the inequality of fractions by multiplying by the LCD, right? You're clearing the fractions. So you only do that if necessary. So if there are fractions there, then you would use this step. Step 2, use the distributive property to remove grouping symbols such as parentheses. So if you have parentheses in your inequality, then you would use this step. Combine like terms on each side of your inequality. That's step 3. Use the addition property to write it as an equivalent inequality. And then step 5 is use the multiplication property to isolate the variable. So you could possibly have all of these steps. You might have some of these steps, but you just take each inequality and solve it based on what you started with. Okay, so here's the first one that we're going to solve. Whoops, I think I skipped one. Here's the first inequality we will solve. Notice that my variable's already on the left, and so I'm going to leave it there. I'm going to subtract 8 on both sides, and that's going to leave me with a positive 15. And then we divide. Notice that we're dividing by negative 5. So because we divided by a negative, let me change this here. Make this a different color. We're dividing by negative 5. So we reverse, right now it's less than or equal to. We reverse it to greater than or equal to negative 3. And so there's our solution set. And then we're going to graph that solution set, and we're also going to write it in interval notation. So on the graph, we go with greater than or equal to, right? So it's going to be a bracket opening to the right, starting at negative 3. I'll draw my line this way. Notice that I'm graphing right on the graph. Some people like to use little squiggle things and all of that. I'm fine with that when you're graphing, whatever you're familiar with. But remember, these parentheses and brackets kind of take the place of the open circle and the closed circle. I don't use that for the graphing. This is how we graph in our textbook. This is how you graph on MyMathLab, so I would prefer that you use the brackets and the parentheses on your graphs. And then this goes from negative 3 to infinity, and that's the interval notation. All right, so let's solve this, and notice we have parentheses in here, so we use distributive property. This is going to be 12 minus 18x is greater than or equal to 12. And then to solve, we're going to subtract 12 on both sides. Negative 18x is greater than or equal to 0. I like to throw some in with zeros so you make sure that you know how to work with those. Notice on this one I said to solve and write the solution set using interval notation. So I didn't actually say to graph, but sometimes it's a good idea to graph. Now you might wonder, do I have to flip the inequality this time because it's a 0? Well, the fact that it's a 0 actually doesn't matter. It's what you're dividing by. We're dividing by negative 18, so we must switch the direction of our inequality because of dividing by that negative number. So that's going to be x is less than or equal to 0. And notice I did switch my direction. Okay. And so let's put this on a graph. You may or may not need to actually graph this, and that's really up to you. In the next section, you're going to need to graph to understand, even if it doesn't tell you to graph. So I think making it a habit to always graph will be a good idea. So this is less than or equal to 0, right? So we're going to negative infinity, and then 0, and 0 is included in the solution set. All right, so that's it for that one. So now we're going to jump into this one that has fractions. And that means we need to use the LCD to clear the fractions, and then that helps us solve an easier inequality. So in this case, the LCD will be 21, right? Because our denominators are 3 and 7. Now, a common mistake is that students forget to multiply the 1. Right? We have to multiply both sides of the inequality. Notice I just wrote it beside each expression in this inequality. And that way you can mark out and use that to help you with this. Right? So 3 goes into 21 7 times. And then we're going to have 7 times what's left in our numerator. Remember, that's a 1 now. 7 goes into 21 3 times, and it's a 1 there. So it's going to be plus 3 times 3x plus 7 is greater than 21. Now this is the inequality we solve. We now have distributive property twice. So distribute the 7. And so 7 minus 14x plus 9x plus 21 is greater than 21. We're going to combine our like terms. We have negative 14 and 9. Negative 5x plus 28 is greater than 21. Be careful with your signs. Notice the 14 is negative, the 9 is positive. And then we're going to subtract 28. A lot of times when you start with fractions, you end up with a fraction answer. To solve, we divide by negative 5. And then my solution set is going to be x is less than positive 7/5. Remember, a negative divided by a negative is a positive. We switch the direction of the inequality from greater than to less than because we divided by negative 5. Okay. So we put this on a graph. Remember, this is optional, but good idea. And it is going to be less than 7/5. I didn't use my line drawing tool there, so it's a little messy. And then in interval notation, we are going to be at negative infinity to 7/5. The 7/5 is not included because remember we don't have that or equal to part. And that's it. I don't want that to look curved and not like it's a bracket because it's not. Okay, let's see what's next. So here's the next inequality we're solving. On this, we notice that we have like terms on the left-hand side, so we're going to combine those, which gives us negative 0.3x is greater than 0.45. It's not necessary to clear decimals. You could if you wanted to. That would just be up to you. We're going to divide then by 0.3, negative 0.3, and then reverse our direction. Notice I give you a lot of these where we're dividing by a negative for practice, and that leaves us with a negative 1.5. Now, once again, you can put this on a graph, but this is less than, so you could just go ahead and write your interval notation from negative infinity to negative 1.5. Parenthesis on both, right, because we don't have or equal to. All right, let's take a look at this one. So we distribute on the right 7x minus 14. Now what I would like you to notice here is something's going on. First of all, I have 7x on both sides. If I subtract 7x, then I get that 0 is less than negative 14. That is false. Would you agree that that's a false statement? And so what happens here is this has to be a no solution or the empty set, right? So on MyMathLab, they usually have you choose the empty set, and you could also, for me, say, or call this no solution, right? Because there's nothing that's going to be a solution for this particular inequality. All right, so this one's kind of a big messy one. We're going to just work our way through this with some distributive property first. So 14x plus 21 plus 4x is greater than or equal to 7 plus 15x minus 20 plus, that's a 1x. Now remember, as you're working through this, you should be pausing and trying these on your own and then watching what I have to say once you've kind of got the hang of it with a couple. Now we do combining like terms, so we have 18x plus 21 is greater than or equal to, that's going to be a 16x minus 13, right? Because I have 7 minus 20. And then from there, I'm going to solve by subtracting the 16x. And you could do this on the same step. I'm also going to subtract the 21. Maybe I should do this in a different color. Do that. All right, so I'm going to subtract the 16x so that my variables are on the left. Subtract 21. So my constant terms are on the right. And so that leaves me with 2x is greater than or equal to negative 34. Notice this time we're dividing by a positive number. So we divide both sides by 2. And x is greater than or equal to negative 17. Now, I didn't say you had to graph this. You can graph it in order to write your interval notation. Hopefully on some of these that are the more simple ones, you can just say, oh, I see what's happening here. But remember, graphing is perfectly fine. And so then you can see that this is going to be a bracket at negative 17. It's greater than or equal to, so we're going to positive infinity. And that is our interval notation. And also the end of this lesson. All right.